We are starting now the problems given in the exercise. First three problems you have already done in class 8. We are starting from the fourth one, that is 4.4. Now listen the statement. A force of 100 Newton is applied perpendicularly on a spanner at a distance of 10 cm from a nut. Find the torque produced by the force. You have to write the given data. Force F 100 Newton. Moment arm of the force is equal to L 10 centimeter. You have to change it into meter, dividing by 100. It is now 0.1 meter. Next heading is to find underline it, but you have to find here the torque. Symbol is torque. Put question mark. Now next heading is formula. Underline it. The formula is tau is equal to F multiplied by L. Now next heading is solution. Solution, underline it. Write down the formula again. Tau is equal to F into L. Now put the values. Tau is equal to F is 100 Newton and L is 0.1 meter. So tau is equal to 10 Newton meter. Now in the end you will write its result. Write down the heading result. Underline it. Result is the torque produced by the force is the torque produced by the force is 10 Newton meter. Now problem 4.5. The statement is a force is acting on a body making an angle of 30 degree with the horizontal. The horizontal component of the force is 20 Newton. Find the force. You have to write the data. Given data. Underline it. Angle. Theta is the symbol for angle. It is equal to 30 degree. Horizontal component of the force component of the force is equal to Fx, and Fx is 20 Newton. To find underline it, force F put question mark. Next heading is formula. Formula you will use here is Fx is equal to F cos theta Now solution. Underline it, write down the formula again. Cos theta, arrange this formula, separate F. F is equal to Fx over cos theta. Now put the values. F is equal to Fx is 20 Newton and cos 30 degree. F is equal to 20 0.866 cos 30 is 0.866. So F is equal to 23.09 Newton, or after rounding off, F is equal to 23.1 Newton. This is the answer. In the end, you have to write the result. Underline it. Now write down the result. Force acting on the body is force acting on the body is is 23.1 Newton. Problem 4.6. The steering of a car has a radius 16 cm. Find the torque produced by a couple of 50 Newton. Given data. Underline it. Radius of steering, equal to R, which is equal to 16 centimeter. Change it into meter, dividing by 100, you will get 0.16 meter. Distance, in order to move the steering or in order to take the turn, two forces are applied which are of same magnitude but not along the same line, and you have to write the distance between the forces, which will be equal to, in this case, double of the radius. So distance between the forces or which is equal to couple arm and it is equal to L, and L is equal to 2 times R. So 2 into 0.16, that is equal to 0.32 meter. Force of couple, that is equal to F, and F is equal to 50 Newton. Now you have to write next heading to find. Underline it. You have to find the torque of couple. Torque of couple. Question mark. Next is the formula. Underline it. Formula is torque of couple is equal to F into L. Here L is equal to AB. If two forces are applied, one is at point A, other is at point B, so L here is representing the perpendicular distance between the forces. Now put the values. F is 50 Newton, L is 0.32. You will get the answer 16 Newton meter. You have to write the answer in words, the result. Underline it. Torque produced by the couple is produced by the couple is couple is 16 Newton meter. Problem 4.8. Two blocks of masses 5 kg and 3 kg are suspended by the two strings as shown in the figure. Find the tension in each string. So first of all, you should understand the figure. The first string in which tension 1 is indicated. This string is holding both of the blocks. So tension in that string is due to the weight of both of the blocks. The second string in which tension 2 is mentioned in the figure, this string is just holding the block of mass 3 kg. Hence, this tension is because of only the weight of this block. Now, write down the given data. Mass of first block, mass of first block, it is m1, and m1 is equal to 5 kg. m1 5 kg. Weight of block m1, now you will calculate its weight. Weight of block, weight of first block, it is W1, and W1 is equal to m1 into g. Now m1 is 5 kg and g is acceleration due to gravity, and its value is 10 meter per second square. So weight of this block is 50 Newton. Mass of second block, mass of second block, it is m2, and m2 is 3 kg. Weight of second block is, weight of second block is equal to W2, and W2 is equal to m2g. Now W2 is equal to, m2 is 3 kg, g is 10, so its weight is 30 kg, 30 Newton, sorry, 30 Newton. To find underline it, tension in first string, tension in first string is equal to P1, and you have to find it. Tension in second string, tension in second string equal to P2, put question mark. Now heading formula, For T1, we are using here the sum of all the forces should be equal to 0. So T1 minus W1 minus W2 equal to 0. For T2 again sum of all the forces is equal to 0. So T2 minus W2 is equal to 0. Now to calculate it, solution heading, underline it, write down the first formula, T1 minus W1 minus W2 equal to 0. We are considering here both the weights because T1 tension in the string is holding both of the weights here. So put the values, T1 minus 50 Newton minus 30 Newton is equal to 0, or T1 minus 80 Newton is equal to 0, or T1 is equal to 80 Newton. Tension in the first string is calculated. Now tension in the second string, write down the formula, T2 minus W2 is equal to 0. Tension in the second string is just holding the second block whose mass is 3 kg or weight is 30 Newton. So put the values, T2 minus 30 is equal to 0, or T2 is equal to 30 Newton. Tension in the second string is calculated. Now you have to write the result. You write both of the result here. Tension in the first string is 80 Newton. Tension in the second string is 30 Newton. Problem 4.9. The statement is, a nut has been tightened by a force of 200 Newton using 10 cm long spanner. What length of the spanner is required to loosen the same nut with 150 Newton force? We will solve this numerical in two parts. First part, force F, given data heading, Problem 4.9. A nut has been tightened by a force of 200 Newton using 10 cm long spanner. What length of a spanner is required to loosen the same nut with 150 Newton force? We will solve this numerical in two parts. The given data for first part is force F, F 200 Newton moment arm of the force, arm of the force, is equal to length of spanner. Length of the spanner. Symbol for moment arm is L, and L is equal to 10 centimeter. You have to change it into meter. Dividing by 100, you will get 0.1 meter. Now in this part we will calculate the torque to find and this torque will be used in the solution of the second part. To find torque, tau is the symbol, put question mark. No. Next heading is formula. Underline it. Tau is equal to F into L. Put the values. Tau is equal to F is 200 Newton and L is 0.1 meter. So answer for tau is 20 Newton meter. This torque is used to find the length of the spanner for the second part. Now second part, given data, underline it. Force F, which is equal to 150 Newton. Torque, tau already calculated, 20 Newton meter. To find underline it, length of the spanner is equal to momentum is equal to L, put question mark. Next heading is formula. Underline it. Tau is equal to F multiplied by L. Solution. Underline it. Write down the formula again. Tau is equal to F into L. Arrange this formula. Separate the symbol which you have to calculate. L is equal to tau over F. L is equal to 20 over 150 Newton. L is equal to 0.133 meter. This is very small value. Change it into centimeter, multiplying by 100. 0.133 multiplied by 100. Now unit is centimeter. L is equal to 13.3 centimeter. This is the length of the required spanner. Now result. Underline it. The length of required spanner is required spanner is 13.3 centimeter.